Okay, today we get to talk a little bit about expressions. Expressions are different than equations, but they are similar, and you will be seeing both over the next few weeks while we are working with expressions. Today we are focusing mainly on identifying the operation based on words that we see. So in the warm-ups that we've been doing, when it says things like triple 9 or double 11, you are creating expressions. So you are already doing what we were about to do right now. So this will go pretty quickly. We've already been practicing it. This is the beginning of algebra. You've already been doing it. It's identifying those words and those phrases. It's identifying those words and those phrases that tell us what operation we are working with. Okay, so when it says a number plus 2, what operation is that? This word's kind of my giveaway.
Addition.
Addition. We have addition, subtraction, multiplication, and division. Okay, the word plus means that we are using addition. What does that look like as an algebraic expression? A number plus 2. That's what it looks like. A number plus 2. We don't know what number it is, so we use an n. The n is called a variable. A variable is something that can change. It means I can plug in any number for that n. I could plug in a 3 if it told me to. I could plug in a 5, and then I could solve it. So n is something that changes, a variable. There is a root or a base word in that word, variable. Vary. If something varies, it changes. Okay, so variables in math are letters that stand or represent a number. It stands for a number, and you can plug in any number. Sometimes you will have a expression given to you, and it'll say use 3 for n. You would plug in 3 where n is and then add 2 to it. You guys saw that in Saxon a lot in 4th grade. So that's not new. We're just now figuring out how to write that as an expression. Okay, the next one says a number minus 4. My key word here is minus. What does that mean to do? Subtraction. And that looks like this, n minus 4. The next one says 3 times a number, which means multiplication. And in algebra, we do not use the x for a time sign. Why do we not use an x?
Because it would look like a letter.
It looks like a letter. It looks like a variable. An x is a very common variable used in algebra. Okay? So we take away the multiplication sign. Sometimes you might see it like this with a dot. And you might also sometimes see it like this. You might have a number in parentheses. Any of those are ways that you can show 3 times a number. That says or, but it's blurry. You just don't use the time sign. We don't use the x multiplication sign anymore because it looks like an x variable. So we have to make sure we either get rid of it completely and just put 3 in the letter, or we can use a dot to represent multiply, or you can separate it with parentheses, okay? All right, a number divided by means division. 5, so that means n divided by 5. You can also see it like this as a fraction. Either one of those. Those are both very, very common ways to see a division problem when we start working with variables in algebra.
It looks like the other one's a fraction.
It is, but a fraction is a division problem because you just divide the top number by the bottom number. Okay, the next one says 6 less than a number. So less than means subtraction, but you have to be very careful about how you write this problem. It is 6 less than a number. So is it 6 minus a number, or is it a number minus 6? It's a number minus 6 because it is 6 less than a number. So n minus 6. Order is very important. You have to be very, very careful. Okay, the next one says 3 added to a number. We know that's addition, but it is a number that has 3 added to it, so n plus 3. Is it as important when we are adding or multiplying the order that we list them in?
Yes. Wait.
Is it as important as like subtraction or division? Does it matter what order we add or multiply in?
No.
No, because we just talked about our properties.
No.
Addition and multiplication can be commutative. You can put the numbers in whatever order you want to. You're still going to end up with the same answer, okay? All right, 6 times a number plus 3. So this is kind of what we're doing, where we have 2 steps now. So 6 times a number would be 6n, and then plus 3.
Wait, why wouldn't you put the sentence times, like the dot or the parentheses in?
So a lot of times you're not going to see like the dot or the parentheses. Those are ways you can write it, but a lot of times you're going to see them just right next to each other. That means multiply.
These answers can answer like almost any number.
You can play, sometimes it'll tell you, like we're going to do some practice, not today, but another day we're going to do practice where it tells you to plug in a certain number for your variable, and you'll actually plug in that number and solve it. Okay, right now we're just practicing identifying words, changing it to an expression, and figuring out what that expression is representing. Okay, the next one says a number divided by 8 less 2. So that could be like this. A number divided by 8 minus 2. You could also write it this way. I'm going to do a different color. You could also do n divided by 8 minus 2. I don't have to use parentheses here because we know that division and multiplication always comes before addition and subtraction because of order of operation rules.
What would the number equal?
Well, it depends on what your number is, what you plug in for n.
Oh, so would it be 4?
So if it told you n equals 16, then I'd have to plug in 16 for n and then do 16 divided by 8, which is 2, and then minus 2, so your answer would be 0. So it just depends on what they tell you to plug in. Right now, this is just an expression. We're not solving anything. Okay, 8 plus a number times 12. 8 plus a number times 12. So what is that going to look like? 8
8 plus n, and then times 12. Dot 12? Oh, no, it's not that.
You could do
It could not be a dot.
times 12 like this. But the problem is first I want to do 8 plus a number, then times 12. So what that's going to look like is parentheses, 8 plus n, and then parentheses 12. Or you could put a dot in between there if you wanted to.
So the answer would be 4.
Well, it depends on what n is going to be. Okay, the last one. A number times 5 less 7. How do I show a number times 5?
N per.
I hope you're paying attention because if you are not, this can get really confusing. So please be sure that we're not having those side conversations. Okay, a number times 5. What can that look like?
N parentheses. And then 5.
Okay, I'm going to write it without any parentheses. I'm just going to do 5n.
Oh.
Number times 5. We typically won't do n5. Like you wouldn't put your variable first attached to a 5. you typically will always have your number first and then your variable after to show that you're multiplying those together. Okay, and then less 7, minus 7. Okay, let's look at the next page. It's like a little half sheet. It looks like this. Oh, let me make it bigger. Okay, so these have a lot of examples. So the first section is all addition, which you might see if it's an addition problem. You might see things like sum, more than, or plus. So the sum of 4 and a number is 12. Notice that they used x this time for my variable. So 4 plus x equals 12. That's what that would look like. Now this is giving you an equation because it's telling you 4 plus a number is 12. 7 more than a number is 21. So n plus 7 or 7 plus n equals 21. A number plus 18 is 32. What does that look like? A number plus 18 is 32. We can't see that.
14. Wait, no.
N
So it would be 18
plus 18 is 32 is what that would look like.
Oh.
Okay, what about subtraction? I have 2 examples. One with the word difference, one with the phrase less than, and my last one is minus. 26 minus a number is 17. 26 minus a number is 17. You used to have problems like this in Saxon all the time. And you would have to use that inverse operation,
Oh, yeah.
the opposite, to solve it
It was
sometimes.
Like 24/7.
Multiplication, we might see the word product or times or the phrase multiplied by. If I have 20 multiplied by a number, that's going to be 20n is 840. How could I solve that problem to figure out what n would equal?
What is 20 times?
Opposite. Right now it's 20 times something.
divide.
Yeah, you would do 840 divided by 20. That would give you your number.
Oh, this is making
Okay.
sense.
And then the last one is division. So a quotient tells me I'm dividing. And then the phrase divided by obviously tells me I'm dividing. So 33 divided by a number is 11. Okay, these are just taking phrases and words, what we've been practicing in our bell ringers, what we just practiced today. You're taking words and phrases and making it into an expression or equation.